Welcome to our first video on bonds. Here, I'll talk about some definitions and then also walk through a basic valuation exercise.
A, a bond is simply a contract that describes how a loan will be repaid. Now, this loan contract has two parties. One's called the issuer, and the other is called the holder or the owner. The issuer of the bond is also called the borrower, and the owner or the holder of a bond would also be called the lender. Okay, so issuer equals borrower and owner or holder equals the lender. Now, to the borrower then, the bond is a liability and it will show up on the right-hand side of its balance sheet. And to the owner or holder of the bond is an asset or an investment, something that generates a potential future return. And so let's go back to the specifics of the contract now. So, as I said before, the contract describes how the loan will be repaid. Now, in a bond, we've got a couple of specific features of this repayment. One is a series of interest-only payments. These interest-only payments are going to occur throughout the bond's life, so typically once every 6 months. This is an example of a bond. This is a McDonald's bond, and so the issuer here is McDonald's Corporation. Now on this bond, we're going to look for a few really important pieces of information. We want the face value, we want the coupon rate, and we want the bond's maturity. First, let's start with the face value. So the face value is also known as par value or the principal amount of the loan. So we can also say par or principal. So the face value here is this number. It's $1,000, and this is typical for bonds. Bonds are often denominated in $1,000 chunks. Now, this does not mean McDonald's is only borrowing $1,000. It simply means that each individual bond is worth $1,000. And so how much would actually show up on McDonald's balance sheet as the liability associated with the bond? Well, it would depend on how many of these certificates they issued. And it is not at all uncommon for these issues to be huge. And so let's just pick a number. We'll make something up. Let's say McDonald's issued 20,000 of these bonds. So if they issued 20,000 of these bonds at $1,000 face value each, their total face value, the total principal amount of the loan, or the total amount of the debt on their balance sheet would be $20 million. A couple of other numbers, the coupon rate and the maturity. Let's look for those. First, the coupon rate is right here, 4.25%. So that's 4.25% coupon. This tells us how much interest as a percent of par value will be paid out each year. And so what does that mean? Well, it means each bond will generate a payment of $42.50 per year. However, coupons are typically made every 6 months, and so this is going to end up being two separate payments of $21.25 occurring every 6 months. Final number we're looking for is the maturity. Maturity is here it's 1993, and if you read the fine print, which is here, you can't see it exactly, but it looks like August, maybe August 2nd-ish. But in this fine print, there will be an exact date in 1993 when this bond matures. And so on at maturity, the par value of $1,000 per bond will be repaid. If you also look in this fine print, you'll see the date this bond was originally issued, and I can't see it exactly, so I'm going to guess. I'm going to guess that it was 1983. And so if this bond was issued in 1983, it means it was issued with 10 years to maturity. And so what are the implications of that? Well, this is at issue, this is a 10-year bond. How many payments will be made? Well, there will be 10 times 2 equals 20 semi-annual coupons plus a single par value repayment at maturity. All right, now that we're familiar with this bond, let's take all of the cash flows that we've identified, put them on a timeline, and then compute an estimate for the value of the bond. And so let's start by just determining how big this timeline should be. Since the cash flows occur once every 6 months, we're going to have a timeline whose tick represents a 6-month period. And since the bond matures 10 years from the date of issue, it's going to have 20 6-month periods in its life. And so our timeline needs to be 20 ticks long. Always start with time 0 to represent the present. And just put some ... here to take us all the way to time 20. Recall that when we construct timelines, we always put the time on top and we put the cash flows on the bottom. And so the cash flows are first a series of coupon payments. And those occur every 6 months from time 1 to time 20. And then second, there is the par value repayment of $1,000 that occurs at maturity. Now let's take a look at what we see and use our toolkit to do something constructive here. And so looking at this series of cash flows here, we've got 2 components, right? And this first component is a level stream. What do we call that? That's an annuity. And then the second one is just a single cash flow. And so if we want to calculate a present value, then I'm just going to calculate the present value of each component separately. And add them together, and we have a present value for the bond. Now, just to be thorough here, I'm going to break this down and I'll show you the formulas. So the present value of an annuity, we know is the payment, and so here payment is $21.25 times an annuity factor, and the appropriate T for this annuity factor is 20. And then the present value of the single cash flow is the cash flow amount in the numerator divided by 1 plus a discount rate, again raised to a T of 20. And so that should be the present value of this bond. We're almost there. One remaining question, of course, is what is R? What's the discount rate here? Well, we have a discount rate that we typically use in bond valuation, and the discount rate is called the yield to maturity, or YTM. The yield to maturity is a market determined discount rate that tells us something about the market's view of the riskiness of the cash flows being valued. And so let's just throw in a number here. Let's suppose the yield to maturity is 4%. Okay. So with a 4% yield to maturity, what do? Do we just take 4% and plug it in for R in the above formula? Well, not exactly, because what we need to remember is this yield to maturity is an annual rate, but we have semi-annual cash flows. So simple adjustment here. We're going to take the yield to maturity and divide it by 2. And so we'll say the semi-annual R is 2%. So let's just insert R equals 2%. Use our favorite calculating device, financial calculator or an Excel spreadsheet, and we will get a present value of approximately $1,020.44. And so what does that tell us? Well, that tells us that this bond with a yield to maturity of 4% should have an approximate price of $1,020.44.